Imagine sinking into a world where mountains hide under miles of water, where glowing creatures drift like living stars, and where entire forests made of coral grow so slowly they make glaciers look impatient. Down here, pressure folds the planet into trenches deeper than Everest is tall. Vents breathe out shimmering heat, and strange animals migrate in the dark with better navigation skills than humans juggling 3 map apps. Even shipwrecks become quiet neighborhoods. Microbial mats build real estate empires 1 grain at a time, and predators hunt not with speed, but with the kind of patience that feels almost philosophical. This isn't a world of chaos. It's a world of calm, quiet wonder. A place where every glow, ripple, shadow, and whisper tells a story older than continents. So join me as we drift across the ocean floor, exploring Earth's most peaceful wilderness, and maybe discovering why the deep sea is the greatest introvert sanctuary in the entire universe. If you look straight down into the ocean, past the shimmering surface and the bustling neighborhoods of darting fish, you start to feel as if you're slipping into a different kind of silence. Not the quiet of an empty room, but something older, thicker, almost padded around the edges. It is the kind of silence that makes you acutely aware of your own heartbeat, like the ocean is politely reminding you that you are the visitor here and not the other way around. As you drift through the upper layers, the sunlight begins to soften. It becomes less like a spotlight and more like the dim, golden glow of a theatre right before the performance begins. The deeper you travel, the more the colours dissolve. Reds vanish first, then oranges fade, then yellows surrender until only cool blues remain, all melting into the calm twilight that marks the beginning of the descent. Most people imagine the ocean as a dramatic place full of thrashing predators and cinematic chaos, the kind of world where everything is either hunting or being hunted. But the truth is that the deep sea is, for the most part, a realm of profound stillness. Down here, things move slowly. Conversations, if fish had them, would probably take hours. Even the animals seem to keep to themselves. In fact, some of the fish drifting around you give the impression that if they could wear hoodies and avoid eye contact, they absolutely would. The deep sea is the universe's largest introvert meetup, and everyone has agreed not to talk about it. As the last of the recognizable daylight slips away, you enter a zone where the world becomes beautifully uncomplicated. No busy coral reefs, no frantic chases, no crowds, just a soft blue haze curling around you, wrapping everything in a quiet glow. It is a bit like walking alone through a library after closing time. Vast, empty, serene, and filled with the feeling that every corner holds secrets you're not sure you're supposed to know. Even the water feels thicker here. Not physically, but emotionally, as if you're swimming through the memory of sunlight rather than the real thing. The descent slows, not because you choose to slow it, but because your senses are adjusting to the new pace. In the deep, rushing feels out of place. The ocean floor is far below you, but already you can feel its mood pressing upward, patient and unhurried. This is a world that has existed for hundreds of millions of years without ever once asking for attention. Its landscapes have grown, shifted, collapsed, and formed again in complete darkness. And not once has it tried to go viral for it. In fact, if you told the ocean floor that millions of people want to watch a video about it, it would probably respond with the same alarmed stillness as someone who suddenly realizes they're being sung "Happy Birthday" in a crowded restaurant. Your eyes continue adjusting to the dimness. Shapes become softer, less defined, as if your brain is unsure whether it should process what you're seeing visually or emotionally. The water itself seems quieter. Even your movements leave behind long, slow trails, like you're brushing your hand through memory foam. In this part of the descent, time behaves strangely. Minutes stretch, hours compress. Everything flows with the rhythm of a place that has never rushed for anything. There is a gentle comfort in that. A reminder that not everything needs to move at the speed of a notification ping. The fish that appear around you aren't the fierce, fang-covered beasts you might expect from movies. Most are small, pale, and incredibly calm, drifting through the water with the vibe of creatures who had plans for today, but decided to take a mental health day instead. One of them glances your way, if you can even call it a glance, and gives off the unmistakable impression of someone quietly hoping you won't start a conversation. Fish in the deep sea are masters of minding their own business, which is probably why they live so long. It is peaceful living, taken to a professional level. As you drift deeper, the world settles into a soft blue-black stillness. The light becomes faint, then faint enough to feel, then faint enough to hold, as if it were a physical thing resting in your hand. But even as the darkness thickens, there is no sense of fear. The deep does not feel hostile. It feels contemplative. It feels like a world where everything has learned the art of patience. And with every meter you descend, you feel more like you're entering a sanctuary than a wilderness. Eventually, the last trace of sunlight fades completely. The blue twilight folds in on itself like the closing of a curtain, and you realize that the journey has truly begun. This is not a plunge into danger. This is a slow, peaceful walk into the unknown. A place where the quiet speaks louder than sound, and where even the fish seem relieved that no one is shouting. Here, the ocean floor waits far below, not with drama or menace, but with the calm confidence of a world that knows it does not need to impress you. It simply is, and that is enough. The deeper you glide, the more the ocean begins to reveal one of its most remarkable tricks. Pressure. Not the emotional kind, though honestly the deep sea seems like the perfect place to go when you need to escape that, but the physical kind, the slowly mounting weight of the entire water column stretching above your head, like a stack of liquid skyscrapers. Most of us rarely think about pressure in everyday life, unless we're dealing with a stubborn jar lid, or pretending not to panic when the tire pressure light flashes in our car. But down here, pressure is the ruling monarch, patient, invisible, and absolutely relentless. It never rushes and never stops. It simply accumulates, layer by layer, like the world's most determined collector. At the surface, pressure is tame. You're dealing with one atmosphere, which feels normal because you've spent your entire life wearing it like an invisible t-shirt. But at just a few dozen meters down, the ocean begins to stack atmospheres on top of you, like someone who keeps adding blankets every time you say you're already warm enough. And by the time you descend a few hundred meters, you're being hugged by a force that would flatten a car like a soda can. The strangest part is that the pressure doesn't feel like it's squeezing you from the outside. It feels more like the entire ocean is gently leaning on you, steadily, politely, with the persistent enthusiasm of a weighted blanket determined to solve all your problems, provided one of those problems is not being a submarine. You may wonder how the animals down here handle it. The answer is deceptively simple. They never had the luxury of choosing anything else. Their bodies are built for it in ways that defy surface logic. Deep-sea creatures don't fight the pressure. They make peace with it. They don't have gas-filled cavities that can collapse like balloons at a birthday party gone wrong. Their tissues, organs, and cells are packed in ways that let them harmonize with the crushing weight around them. It's like they're born already wearing pressure-proof pajamas. They just exist. And the ocean, for its part, respects their calm acceptance. Pressure behaves predictably, which is both comforting and terrifying depending on your relationship with structural engineering. For every 10 meters you descend, pressure increases by another atmosphere. 10 meters. That's less than the length of most living rooms, and yet it's enough to add another full layer of invisible weight pressing on you. Imagine climbing down a staircase where every single step comes with an extra gravity pack strapped to your shoulders. Except the packs never come off, and the staircase never ends. The deep sea does not deal in small numbers. It deals in slow, unstoppable accumulation. But the really fascinating part is not the numbers. It's how the ocean itself carries this weight with almost indifferent grace. Water is practically incompressible, which means it doesn't buckle or give way under pressure the way gases do. Instead, it absorbs the force and transfers it seamlessly through its entire volume. The ocean isn't resisting the pressure, it's sharing it. If water had a personality, it would be that calm, grounded friend who always knows how to distribute responsibilities during group projects. As you descend farther, the sensation changes yet again, not in pain, but in awareness. You begin to realize why submarines are engineered like metallic tortoises, all curved edges and thick walls. The ocean isn't actively trying to crush anything. It's merely expressing the natural outcome of a planet covered by an unimaginably deep layer of water. Pressure is simply the tax you pay for choosing to visit a world that operates under an entirely different rulebook. But humans, being humans, couldn't resist exploring this territory anyway. We built machines with hulls thicker than most people's patience, then sent them plunging into the dark to see how far we could push our luck. Some of the earliest deep-sea vessels creaked loudly enough during descent to make even the bravest researchers reconsider their career choices. Imagine sitting in a metal sphere, listening to it groan like an old house settling, but knowing that, unlike a house, you are surrounded by enough pressure to turn steel into modern art. And yet, despite all this, there is something strangely calming about how pressure behaves. It isn't chaotic. It isn't unpredictable. It doesn't throw surprises your way. It rises steadily, mathematically, like a metronome marking the rhythm of descent. You can calculate it, anticipate it, prepare for it. In a world where so many forces of nature behave like unpredictable toddlers, pressure is refreshingly adult. As the descent continues, you can feel the weight of the ocean becoming not something oppressive, but something grounding. The analogy of a weighted blanket becomes increasingly fitting. Some people find comfort in the gentle, evenly distributed pressure that makes them feel anchored. The ocean, however, takes that concept and scales it up with the enthusiasm of a cosmic overachiever. It's soothing on a conceptual level. Less so if you are made of metal and bolts. The water column seems to offer you this hug with a serene smile, unaware that its affection would implode most objects known to engineering. And still, the journey goes on, deeper and deeper, where the pressure rises, not with drama, but with absolute, unwavering confidence. It does not announce itself. It does not rush. It simply continues, a constant reminder that down here, the rules are different. And understanding those rules is the first step in learning how to explore a world that thrives under a weight we can barely comprehend. As you continue your quiet descent, the world beneath you slowly transforms from shadowed emptiness into something unexpectedly vast and pale. The first hints of the seafloor appear, not as dramatic cliffs or jagged mountains, but as a sprawling, endless blanket of soft sediment, stretching toward the horizon like an ocean made of powdered moonlight. It looks still, unbelievably still, like someone pressed pause on a landscape. But that stillness is an illusion, the kind that only the deep ocean can pull off with a completely straight face. Nothing down here is actually frozen. Everything is shifting, settling, drifting, or rearranging itself in ways so subtle that you could stare for hours and miss the entire performance. Sediment plains form slowly, in the kind of timeline that makes glaciers look impatient. Every speck of material drifting through the water column, shell fragments, mineral particles, microscopic plankton skeletons, grains of rock shaved off by ancient waves, eventually sinks. Gravity is patient and absolutely undefeated. Over millions of years, these tiny fragments gather, layer upon layer, until they create enormous underwater deserts that are anything but deserted. If you could scoop up a handful of this soft floor, you'd be holding a time capsule made from the wreckage of past oceans, past climates, past worlds. Each grain has travelled farther and seen more geological drama than most people on vacation, which makes sense because some of these grains began their lives on mountains, wandered down rivers, toured continental shelves, and finally decided to retire here on the abyssal plains. They are tiny, well-travelled retirees with very dusty passports. The plains are deceptively simple at first glance. To the untrained eye, it looks like a giant underwater sandbox where nothing happens. But if you zoom in, really zoom in, you discover it's one of the busiest ecosystems on Earth. Beneath the top, few centimeters of sediment, lies a bustling underworld of worms, burrowers, bacteria, and tiny crustaceans who treat the muddy surface like a construction site. These organisms build tunnels, sift through grains for food, and recycle nutrients with the efficiency of a world-class cleaning crew. To them, every grain matters. Every grain is either a meal, a hiding place, or part of a tunnel that leads to more grains that hold more meals. It's like living in a neighborhood made entirely of eatable dirt walls. And while the plain looks flat enough to play billiards on, it's actually shifting all the time. Not in great sliding sheets or dramatic avalanches, but in slow, silent shuffles. Deep currents sometimes sweep across the floor, lifting the lightest particles and sending them drifting like underwater snowstorms. Burrowing animals bulldoze tiny mounds, only for water movements to smooth them down again. Even the slightest tremor from distant tectonic murmurs can send ripples through the sediment, rearranging it without leaving any visible clues. Its movement so delicate that if the seafloor were a stage, the actors would be performing in microscopic slow motion. What truly surprises most people is how alive the plains feel when you stop thinking of them as mud and start thinking of them as unseen life support. Much of the ocean depends on these gentle, pale landscapes, even though most creatures will never visit them. Organic material from dead plankton, fallen kelp, drifting jellyfish, and anything else that stops being buoyant eventually comes to rest here. The sediment plain is a kind of quiet caretaker, breaking it all down, recycling it into nutrients that seep back into the water and ripple upward through the food web. It's the ocean's version of composting, just stretched across thousands of miles. But life here has adapted to extraordinary stillness. Many animals spend their whole existence sifting through sediment for particles of food so small you'd need a microscope to appreciate them. Some worms move only a few centimeters per day. Some bacteria barely move at all, content to live out their microbial lives in the same square millimeter. If patience were an Olympic sport, the sediment plain would be the training grounds. Every so often, though, the plains experience a surprise, something falling from above. It could be a fish that died hundreds of meters up. It could be a clump of algae swept off a distant shelf. It could be, on rare occasions, a whale carcass descending like a planetary event. When something large lands, the quiet plain wakes up. Scavengers appear seemingly out of nowhere, drawn by chemical signals carried on the faintest of currents. Creatures that normally act like they're part-time employees suddenly treat the site like it's hosting a festival with free catering. Despite its calm facade, the sediment plain has a subtle beauty. Light doesn't reach this far, but the soft texture of the floor reflects the faint glow of your instruments in muted patterns that look like ripples of old silver. If you stare long enough, it begins to resemble a distant desert beneath a moonless sky, the kind of landscape that invites reflection and a little awe. You get the sense that the plains have been here far longer than anyone has been around to appreciate them, and will remain long after you leave, continuing their slow dance of drifting grains and quiet life. As you drift across this quiet expanse, you realize something unexpected. This soft, pale floor, which looks so unassuming, is one of the ocean's most important foundations. It's the quiet caretaker, the recycler, the memory keeper. And while it may look like the ocean's version of beige carpeting, it holds more stories, more life, and more history than any flashy reef or towering ridge. If these grains could talk, they'd probably brag about their unbelievable travel itineraries. And honestly, they'd have every right to. As you leave the pale sediment plains behind, the landscape ahead begins to shift into something far more dramatic. Though dramatic in the way a quiet person suddenly revealing they have a secret talent for fire dancing is dramatic. At first, the seafloor looks dark and solid, ridged like cooled candle wax. Then, faint shimmering distortions appear in the water, like the deep sea is exhaling sighs of heat that bend the world behind them. These are the first whispers of the hydrothermal vent fields, and approaching them feels like gliding toward an underwater city built entirely out of minerals and miracles. The temperature down here has been steady so far, cold enough to make ice feel overly optimistic. So the idea that the ground beneath you is about to start releasing superheated water seems wildly out of character for such a quiet world. Yet that is exactly what the vents do. They are the deep sea's version of hot springs. Except instead of spa treatments and soothing music, you get mineral-rich jets of fluid roaring out of the Earth's crust with the enthusiasm of a pressure cooker that finally found its purpose. Hydrothermal vents form because the seafloor is not a passive layer of dirt and rock. It is a constantly shifting mosaic of tectonic plates. Where these plates pull apart, water begins to seep into the newly formed cracks. That water then trickles downward, deeper and deeper, until it reaches pockets of magma-heated rock. Down here, the water is heated far beyond the boiling point you know from your kitchen. But boiling doesn't happen because the pressure is so intense it forces the water to stay liquid, even when it reaches temperatures that would make your kettle reconsider its life choices. Eventually, the superheated water, now loaded with dissolved minerals, rushes back upward and erupts through chimney-like openings in the seafloor. Despite how dramatic this sounds, vents do not explode like underwater volcanoes throwing tantrums. They don't blast rocks into the water or turn the ocean into soup. Instead, they release their heat with a patient, unwavering flow. Think of them not as volcanoes, but as planetary teapots, always simmering, always releasing steam, never losing their composure. The reason they don't explode is that the system is in perfect balance. Cold seawater enters, hot fluid exits, the cycle repeats. It is a steady exchange rather than a pressure build-up. The Earth, it turns out, knows how to manage a geothermal budget. The chimneys built around these vents grow from minerals that precipitate out of the hot fluid as it meets cold seawater. Over time, these chimneys can tower dozens of meters high, sometimes looking like dark cathedral spires, and other times resembling stacks of fragile mineral lace. They grow upward and outward, layer by layer, until they collapse under their own weight, and then rebuild themselves in new shapes. It's an architectural style best described as Gothic industrial, with strong self-repairing tendencies. But the real magic begins when you notice that these vents, despite spewing hot, mineral-loaded water, are not barren wastelands. They are bustling ecosystems, absolutely thriving in conditions so extreme they make deserts look welcoming. The secret behind this biological wonder is chemosynthesis, a process by which bacteria use chemical energy instead of sunlight to fuel life. These microbes live right at the boundary where scorching vent fluid meets icy seawater, and they flourish there with the confidence of creatures who know they run the hottest nightclubs on the planet. And they truly do. Their dance floors are packed with shrimp, crabs, snails and fish that gather around the chimneys like VIP guests, hoping to get on the list. The bacteria form mats that look like thick carpets or fuzzy coatings on the rocks. Some even live inside animals, forming partnerships so intimate that calling them roommates would be an understatement. These microbes take the chaotic chemistry of the vent fluids, hydrogen sulfide, methane, metals, and spin them into life-sustaining compounds. They are Earth's most underappreciated chemists, working shifts in absolute darkness and never complaining about ventilation because, well, the ventilation is literally a jet of boiling minerals. What surprises you most as you float among these spires is how peaceful everything feels, despite the intense physics happening beneath your feet. There is no roaring sound, no bubbling cauldron effect, no fiery chaos. Instead, the vents release their heat in silent, ghostly plumes, and the animals gather around them with the graceful certainty of creatures who know exactly what they're doing. Even the shimmering water, hot enough to cook dinner, cold enough a few centimeters away to freeze it, seems to exist in perfectly negotiated truce. If you hover close enough, though not too close unless you enjoy dramatic temperature swings, you might feel the faintest hint of warmth. It's like brushing past a radiator someone accidentally left on in a room otherwise chilled to the bone. It's a reminder that the planet itself is not a static ball of rock, but a living, breathing engine, with heat circulating through its veins. And as you drift away from the vent field, watching the shimmering plumes rise into the dark water like silent smoke signals, you realize something unexpected. This is not a place of chaos, but of astonishing balance. Heat and cold, chemistry and life, minerals and microbes, all woven together in quiet harmony, with bacteria hosting the universe's smallest, hottest parties, deep beneath a world that has no idea they exist. Leaving the vent fields behind, you drift into a region where the seafloor seems strangely calm, almost suspiciously so. It feels like stepping out of a bustling geothermal city and into a quiet countryside. If that countryside were dotted with patches of bubbling methane and landscapes that exhale chemicals like a polite dragon with impeccable manners. These are the cold seeps, places where the earth leaks its hidden gases, not with the volcanic flare of a vent, but with the understated elegance of a planet that prefers subtlety. Cold seeps get their name, not because the water is particularly chilly, everything down here is chilly, but because the fluids escaping from the seafloor are not heated by magma. Instead, these seeps release a gentle flow of hydrocarbons, methane, hydrogen sulfide, and other chemical delights that would send most surface creatures running for the nearest exit. Here, though, this is prime real estate. To the wildlife that calls this landscape home, These chemicals are not toxic waste. They're lunch, dinner, and a versatile snack menu all rolled into one. At first glance, a cold seep looks understated. The sediment is pale, but certain patches gleam with a faint whitish crust, as if someone tried to frost the seafloor with an uneven layer of mineral icing. These crusts are made of carbonates that form when seep fluids react with seawater. In some places, the crust grows thick enough to form chimneys, slabs, or even ridges, transforming the plain into a textured mosaic of chemical rockwork. It's not flashy, but it's absolutely unique, an architecture shaped not by heat or currents, but by the slow dance between methane and minerals. Then, somewhere nearby, you notice the bubbles. Tiny spheres of methane wiggle their way out of the sediment, drifting upward in slow, hypnotic spirals. They rise with the kind of lazy persistence you'd expect from gas with nowhere important to be. Each bubble a reminder that beneath the crust lies a labyrinth of pockets and channels pulsing with hydrocarbons. These methane bubbles aren't rushing, they're strolling, like they're taking the scenic route to the surface. You almost expect one to pause halfway and check a tiny map. But what makes cold seeps extraordinary isn't the bubbles or the crust. It's the life. Here, in a place where sunlight is completely absent and the temperature hovers near freezing, communities thrive with a confidence that borders on defiant. The trick, once again, is chemosynthesis. Bacteria colonize the seep sites, feasting on methane and sulfide. And in doing so, they form the foundation of an entire ecosystem. You can find them coating rocks, clustering in mats, or living inside animals that treat them like personal chefs. The stars of the show are the seep mussels, clams, and tube worms, animals that look surprisingly calm, given that they rely entirely on internal bacteria to feed them. These creatures filter or absorb the seep chemicals, hand them off to their microbial partners, and let the bacteria turn those chemicals into food. It's a symbiosis so elegant that it makes you wonder why surface animals haven't adopted the strategy. Imagine never needing to grocery shop again because your internal microbes negotiated an all-inclusive dining plan. Among all this activity are the tiny ranchers, amphipods, shrimps, and small snails that graze on bacterial mats the way farmers tend fields. They don't wear hats, sadly, though you can't shake the feeling they deserve them. They move in busy little clusters, scraping and nibbling, cultivating patches of microbes with the seriousness of creatures who understand that their entire diet grows directly under their feet. Some species even clear space in the sediment, encouraging fresh bacterial growth, the way a gardener preps soil for new crops. If you ever doubted the agricultural instincts of small crustaceans, cold seeps will change your mind. As you glide farther into the seep field, the smell doesn't reach you, fortunately, but the chemistry shifts subtly in the water. Instruments would detect the increase in methane and sulfide long before you spotted the animals, but once the communities appear, they are unmistakable. Clusters of mussels gather like tightly packed neighborhoods, each shell gleaming faintly under your lights. Tube worms rise in crimson-tipped bundles like underwater bouquets. All around them, bacterial mats form pale, fuzzy carpets that would look cozy if they weren't essentially chemical factories. Every part of this ecosystem speaks to patience. Cold seeps can last for centuries or even millennia, slowly releasing hydrocarbons in a steady, unhurried flow. In the world of geology, they are gentle, persistent leaks, not dramatic bursts. Over time, entire communities build their lives around this stability, growing slowly but confidently. Nothing rushes here, nothing panics. Even the bubbles seem relaxed. There's also a sense of eerie harmony to the place. No sunlight fuels it. No photosynthesis exists here. This is pure chemistry turned into life by organisms who have mastered the art of using whatever the earth gives them. In a strange way, cold seeps feel like quiet settlements, small towns built around natural springs, not of water, but of methane. The animals cluster close, the bacteria thrive on the seeps, and the entire community hums with a gentle, subdued energy. As you rise slightly to look back across the seep field, the scene is astonishing for its contrast. Delicate animals thriving in a landscape shaped by invisible gases, tiny ranchers tending microbial crops, and methane drifting upward like the world's most laid-back celebration. It's impossible not to smile at the thought that, in a realm so cold and dark, life has found a way to create bustling neighborhoods powered entirely by chemistry and patience. Cold seeps don't glow like vents or stretch into endless plains like the sediment basins. They simply are. Quiet, subtle, and absolutely remarkable. A small reminder that even in the most understated corners of the deep, life is endlessly creative. And occasionally, it even remembers to farm, just without the hats. As you leave the chemical gardens of the cold seeps behind, the seafloor stretches out once again. But this time it is no longer the soft, uninterrupted plain you floated over earlier. Instead, the ground beneath you begins to lift and swell in quiet, rolling forms, like the ocean floor is breathing slowly, raising itself in long, gentle waves. These are the abyssal hills, the most widespread landscape on Earth that almost nobody has ever heard of. They are everywhere, stretching for tens of thousands of kilometers, forming a massive underwater quilt of ridges and slopes. And yet, for all their size, they remain astonishingly modest. If mountains could blush, this is how they would hide, beneath miles of seawater, politely declining attention. Abyssal hills are the deep sea's secret architecture. They don't rise sharply or tower dramatically the way continental mountains do. They're more subtle, broad humps that swell upward before sinking back into shadow. Most are only a few hundred meters tall, but they stretch on for vast distances, forming repeating patterns that ripple across the sea floor like the fingerprints of tectonic forces. If the ocean floor were a giant sheet of paper, the abyssal hills would be the faint, textured ridges pressed into it by the heavy hand of Earth's internal machinery. The hills form mainly through tectonic processes, particularly the slow, continuous spreading of the seafloor at mid-ocean ridges. As new crust emerges from beneath the tectonic plates, it cools, cracks, and buckles, creating long lines of elevated terrain. Over time, these ridges break and shift further through faulting, tiny earthquakes that adjust the crust like a spine stretching itself after a long slumber. What emerges from these processes isn't a dramatic mountain range, but a series of gentle, undulating hills. They are mountains, yes, but mountains that have chosen the path of subtlety. If you asked them for their opinion on volcanic eruptions, they'd probably sigh and say, "Too loud." From above, drifting silently through the dark water, the hills look like the backs of sleeping animals, curled up under blankets of sediment. Their slopes are smooth in some places, jagged in others, marked by cracks and crevices that hint at the forces shaping them from below. If you could drain the ocean like pulling the plug on a cosmic bathtub, the abyssal hills would spread out like a hidden landscape of rolling geology no one ever imagined existed. But down here, in the deep, they reveal themselves only to those willing to travel into the dark. Even though they appear calm, the abyssal hills are constantly evolving. Tectonic plates rarely sit still. They grind, stretch, and shift at speeds comparable to the growth of fingernails. Slow, yes, but relentless. Each nudge and pull deep below the crust sends tiny tremors through the hills. Sometimes these movements open small fissures. Sometimes they lift sections of crust by a few centimeters over centuries. These aren't the dramatic, news-making quakes of the surface world. They're more like the Earth quietly adjusting its posture, trying to get comfortable. The hills also play a crucial role in shaping ocean currents. As deep water flows across the seafloor, these subtle ridges guide and deflect its movement, creating swirling eddies and pockets of turbulence. The currents brush along the slopes, eroding some areas while depositing sediments in others. Over time, the hills become sculpted by this slow-motion dance of water and rock. They are geological sculptures made not by wind or rain, but by the silent push of deep currents that no human ever hears. Life finds ways to claim the hills too, though not with the same density seen at vents or seeps. Scattered organisms cling to their rocky faces, using the elevated slopes as platforms to catch drifting food particles. Small sponges, quirky starfish, delicate anemones, and squat lobsters occasionally appear, each creature suspended in the vast quiet, like ornaments hung lovingly on an enormous, dark tree. The elevation provides tiny advantages: slightly faster current flow here, slightly more exposed rock there. On the abyssal plain, even the smallest environmental change can feel like prime real estate. In some places, volcanic rocks poke through the sediment like the stony remains of forgotten sculptures. These outcrops are often the clue that scientists use to trace the history of the crust. Reading magnetic stripes or analysing rock chemistry to understand the tempo of past tectonic activity. The hills are like geological diaries, though written in a language that requires a degree in patience to decipher. And yet, despite being everywhere, covering nearly half of Earth's surface, the abyssal hills are still relatively unexplored. Their sheer scale makes detailed mapping difficult, and their gentle slopes don't attract the same attention as dramatic trenches or towering seamounts. They are the introverts of the underwater world, vast, important, and quietly minding their own business. You can travel for kilometers across the hills and feel the strange illusion that you are gliding over landscapes that don't want to be noticed. It's as though they're whispering, "Please, don't make a big deal about us. We prefer staying under the radar," or under the ocean, in this case. As you continue drifting above the rolling terrain, the hills blur into a rhythmic sequence, rising and falling like slow waves frozen in time. There's a soothing quality to the landscape, predictable without being monotonous, subtle without being empty. It's easy to understand why this part of the seafloor is often described as peaceful. Nothing here feels rushed. Nothing demands attention. Even the mountains, it seems, have decided to lie low, quietly shaping the deep sea while hiding beneath miles of water, as if the very idea of appearing on a map might be too much social pressure. In this gentle topographic world, the ocean floor finally feels less like a frontier and more like a landscape that has existed forever. Calm, ancient, and perfectly content to remain unseen. As you drift away from the gentle hills, something strange begins to happen in the dark water around you. It's subtle at first, like a faint sense that the emptiness isn't quite as empty as it looked a moment ago. Then, gradually, the water thickens with movement. Shapes appear, shadows swarm, A haze of tiny bodies fills the space above, below, and around you until it feels like you're suddenly floating in the middle of a silent rush hour commute. This is the deep scattering layer, one of the largest, most mysterious gatherings of life on the planet. A layer so dense with animals that during World War II, sonar operators thought it was the seafloor itself, rising and falling each day like some sort of breathing ocean giant. The truth, as it turns out, is even more fascinating. The deep scattering layer is made up of billions of small organisms, fish, shrimp, squid, jellies, and other drifting creatures, who all take part in the largest migration on Earth. Not the migration of wildebeest or monarch butterflies or whales. No. This one happens every single night, stretching across every ocean, performed by animals small enough to fit in your hand and numerous enough to reshape sonar maps. During the daylight hours, the layer sinks deep into the ocean, settling into darkness far below the reach of even the boldest surface sunlight. Down here, these creatures blend into the abyss, protected from hungry predators who rely on vision. But when night falls and the upper waters turn dark, the entire layer rises, slowly, steadily, methodically, toward the surface. It's like watching the world's quietest elevator begin its ascent, except instead of people in business attire, the passengers are fish with glowing faces, shrimp with translucent bodies, and squid who seem to be practicing interpretive dance, whether they mean to or not. This nightly routine is called diel vertical migration, though honestly, it could just as well be called a commute. The animals move up to feed under the cover of darkness where plankton is abundant, then return to the deep at dawn before predators wake up and start looking for breakfast. If the surface ocean is a bustling daytime city, then this migration is the night shift clocking in. And among all these commuters, this swirling crowd of drifting bodies, one particular group stands out with noticeable flair: the lanternfish. If anyone in the deep scattering layer wins the Best Dressed Employee award, it's them. They arrive at the nightly commute wearing bioluminescent patterns that look like they spent hours picking out outfits. Tiny glowing dots line their sides in neat rows, like someone bedazzled them with tiny stars. These lights aren't just aesthetic choices. They help the fish blend into the faint light coming from above, making their silhouettes vanish to predators watching from below. Fashion and function joining hands in the dark. Classic lanternfish behavior. The remarkable part of this migration is not only its scale, but its consistency. Night after night, year after year, generation after generation, the layer moves in a steady rhythm that would make even the most punctual office worker proud. And it's not fast. No one is racing. No one is pushing the closed door button on the elevator. The ascent takes hours, and the descent takes just as long, giving the whole event the vibe of a very patient group of travelers who refuse to rush, no matter what deadlines plankton might impose. For the animals involved, this slow movement is essential. Rising too fast would expose them to predators. Staying too long near the surface after dawn would do the same. The timing is finely tuned. In some places, the migration begins the moment the upper waters dim just enough for the animals to trust the darkness. In others, the layer waits, hovering in the deep until the precise moment light levels drop below a safe threshold. They are, in their own way, experts in workplace timing. It's also a massive engine of nutrient transport. When these animals rise to feed at night, they consume food near the surface, and then carry that energy downward when they return to depth before dawn. They release waste at depth, effectively transporting carbon from the surface waters into the deep ocean. This makes the migration one of the planet's most crucial biological pumps, quietly helping regulate Earth's carbon balance without ever receiving credit. If awards existed for ecosystem services, the deep scattering layer would definitely win most hardworking group project participants. As you float among the rising layer, it's impossible not to feel a sense of awe at how many lives are moving in concert around you. Tiny fish shimmer in your lights before darting away. Squid flicker past like living punctuation marks. Shrimp drift in loose clusters, kicking their legs with determined little motions that make them look like they're late for something important. Everywhere you look, animals are moving upward in graceful, unhurried waves. A slow-motion parade that stretches farther than your eyes can see. But the moment dawn threatens, the mood shifts. The water brightens slightly, just enough to trigger an instinct older than continents. Without hesitation, the entire layer begins to sink. The elevator heads back down. The commuters return home. The billions of organisms who filled the water a moment ago vanish into the dark, like a dream receding from memory. Within minutes, the water feels empty again, as if the migration never happened. And yet it will happen again, tonight, and tomorrow, and every night for as long as the oceans exist. This slow, elegant commute is eternal, a heartbeat of the planet that few ever witness. But down here, drifting in the silence, after the layer sinks back into darkness, you know the truth. The deep ocean is alive with rhythms, schedules and migrations as steady as the turning of the earth, led by lanternfish who show up every night impeccably dressed. As you continue drifting through the deep, the darkness settles around you like velvet, soft, thick and absolute. There is no sunlight here, no flicker from above, no glow of anything familiar. The only light that reaches this realm is the one that life itself creates. And just when you begin to adjust to the idea that the world around you might remain forever black, the darkness stirs. A faint glimmer appears, then another. And slowly, delicately, the deep begins to sparkle. It's not bright, not overwhelming, just a quiet glow, like someone sprinkled stardust across the water. This is bioluminescence near the seafloor, the softest fireworks show on the planet. Up near the surface, bioluminescence often comes from swirling blooms of plankton or startled fish flashing their defenses. But down here, on the edge of the abyss, the glow is more deliberate, precise, strategic. It arrives in small pulses, gentle flares, and drifting sparkles that look like the deep sea is trying its best to whisper in the language of light. There is something poetic about it, something deeply calm, as if the creatures of the deep are practicing their own version of Morse code. Bioluminescence is a chemical reaction. Biology's answer to creating light without heat. Two main components make it happen, a molecule called luciferin and an enzyme called luciferase. When the enzyme acts on the molecule, the energy released becomes light. And just like that, darkness is no longer entirely dark. There are variations on this reaction, of course. Some species use slightly different compounds, different enzyme helpers, or different chemical triggers. But the result is the same. A soft glow that dances through the water in blues, greens, and occasionally ghostly whites. What makes this even more astonishing is how efficient the reaction is. Almost all the energy becomes light, not heat, which is important because adding heat to this environment would be about as welcome as a bonfire in a freezer aisle. The organisms have perfected a kind of cold light, the sort that human engineers have spent decades trying to imitate without ever truly matching its elegance. The deep sea glows because the chemistry of life is clever, ancient, and entirely unbothered by patents. As you move through the dark, small organisms drift past, each carrying its own tiny lantern. Jelly-like creatures pulse with internal glimmers, their bodies lighting up from the inside like floating lanterns. Some animals release little dots of light that trail behind them, turning their escape paths into glowing dotted lines. Like the ocean is tracking their route in real time. Others produce flashes so brief you almost doubt you saw them, like distant stars blinking in and out of existence. One of the most mesmerizing sights comes from comb jellies, transparent, delicate creatures whose rows of hair-like cilia shimmer with iridescent light as they move. They don't technically bioluminesce. Instead, their cilia diffract whatever tiny traces of light exist. But down here, the effect is so surreal that it hardly matters. A comb jelly, drifting through the dark, looks like a floating rainbow that misplaced its cloud. But many creatures do use bioluminescence intentionally, and each species has its own reasons. Some use light to communicate, a flash here, a flicker there. Some use it to confuse predators, erupting in sudden brilliance like a flashlight aimed straight into someone's eyes. Others use it to attract prey by dangling glowing lures, as if the deep sea were running a cosmic fishing competition. Meanwhile, certain species live symbiotically with bioluminescent bacteria, outsourcing their glow like creatures hiring full-time lighting technicians. Predators often use bioluminescence as bait. A dangling lure might look like a stray snack to smaller animals, but it is, in fact, the equivalent of a glowing open sign above a trapdoor. Prey, on the other hand, may release clouds of glowing particles behind them as they flee. It's the underwater version of tossing confetti into a pursuer's face, dramatic, messy, and surprisingly effective. There are also animals that use bioluminescence to signal mates, which adds a certain romantic flair to the deep sea. Imagine courtship rituals written in glowing script on the darkest canvas imaginable. And then, of course, there are species that glow simply because the bacteria they host insist on it. These microbes continue shining regardless of whether their animal host is busy hunting, hiding, or minding its own business. It's like having a roommate who won't turn off the hallway light. What's especially enchanting about encountering bioluminescence near the seafloor is how gentle it all feels. There are no violent bursts of light, no sudden blinding flares. The glow here is soft and contemplative, drifting slowly with the currents. Sometimes you catch a glimmer inside a burrow, where a creature flashes at your presence before retreating deeper. Sometimes you see a faint glow drifting upward, carried by an animal so small you can barely see its outline. The glow highlights the shape of the landscape too. A small slope becomes visible for a moment when a fish darts past with a glowing patch on its body. A bit of rock glimmers faintly as a cluster of tiny shrimp ripple through, shedding sparks like embers. The darkness reveals itself only in brief, scattered moments, illuminated by the life that moves through it. It's hard not to smile when you realize that long before music festivals invented glow sticks, the deep ocean had already perfected the concept. These organisms don't need concerts, crowds, or techno beats. They shine because shining is part of who they are. Their glow is ancient, older than humanity, older than forests, older even than many mountain ranges. It's a testament to how creative life can be when confronted with absolute darkness. As you drift onward, surrounded by soft points of light, the deep ocean feels less like a void and more like a quiet galaxy. The seafloor beneath you remains dark, but the water around you pulses gently with living stars. For a moment, the deep no longer feels empty. It feels luminous, alive, and beautifully, softly bright in all the places you least expect. As the soft glimmers of bioluminescence fade behind you, the seafloor begins to tilt downward, not in a gentle slope like the abyssal hills, but in a long, steady plunge that feels as if the earth itself is exhaling. The landscape stretches ahead, like a mouth opening into shadow. This is the beginning of the trenches, the deepest cuts in the planet's surface. They are narrow in some places, wide in others, but all share one defining characteristic. They go down farther than any other place on Earth, into darkness so complete it makes the surrounding ocean seem bright by comparison. Trenches exist because the Earth's crust is not a single unified shell, but a jigsaw puzzle of tectonic plates. Where two of these plates collide, one is often forced downward under the other in a process known as subduction. The descending plate bends as it sinks, and that bend forms a long, deep scar in the seafloor, a trench. Imagine the surface of the Earth as a giant conveyor belt made of rock. One part slides under another. The belt dips, and the result is a gorge so deep that if you dropped Mount Everest into it, the peak would still be underwater. Trenches are the quiet places where continents meet their fate, slowly sinking into the planet's interior, like VIP guests who chose the disappear completely option on an invitation. The descent into a trench feels different from everything you've experienced so far. The world grows narrow, the walls rising on either side like cliffs made of night. The slope becomes steeper, the water colder, the silence thicker. Even the faint sense of space that existed on the plains and hills seems to shrink. It is not claustrophobic. There is plenty of room. But the darkness is older here, more settled, as if it's been waiting a long time. The pressure in a trench behaves in ways that amplify everything you've learned. It still increases steadily, still builds layer by layer. But here it reaches extremes that feel almost abstract. At these depths, pressure is not just a force, it's a presence. It presses equally in every direction, not as a sharp or crushing sensation, but as an immense, unyielding weight carried effortlessly by the seawater itself. The creatures that live here don't merely tolerate it, they are built from the molecule up to thrive within it. Their proteins stay flexible, their membranes stay stable, and their bodies avoid any air-filled structures that could collapse like deflating balloons. Down here, the rules of survival are rewritten with pressure as the author. If vents were like underwater cities and cold seeps like countryside settlements, then trenches are more like quiet sanctuaries, complete with natural "do not disturb" signs posted around their geological borders. Everything about them radiates stillness. Predators are slow-moving, cautious figures drifting in the dark. Scavengers move with deliberate patience, conserving every ounce of energy. Even the sediment looks undisturbed, as if footsteps, if anything had feet, would remain visible for decades. It's the kind of place where if you whispered, you would immediately feel the urge to apologize for the noise. Life does exist here, though it keeps its profile low. Certain amphipods thrive in these crushing depths, surprisingly lively despite the conditions. Some snailfish species, pale, gelatinous, soft-bodied, swim gracefully through the trenches, like ghosts who learned choreography. These fish have bones so lightly mineralized they border on jelly, making their bodies flexible enough to withstand pressures that would reduce most animals to oddly shaped souvenirs. They glide through the darkness with an elegance that feels almost serene, as if they've mastered the art of living so quietly that even the deep itself doesn't notice them. The food supply here is scarce, arriving mostly in the form of organic pieces drifting ever downward from far above. When something substantial lands in a trench, a fish, a jelly, or the occasional large carcass, It becomes the event of the decade. Scavengers converge, moving from all corners with surprising speed, as though someone rang a dinner bell only they can hear. The feast is efficient, respectful, and brief. In a place where energy is precious, nothing is wasted. The walls of the trench offer their own kind of mystery. Some are jagged, lined with rock that looks torn and folded from ancient tectonic stress. Others are smooth, draped with fine sediment that has been sliding down the slope for centuries. Crevices hide pockets of life. Outcrops jut outward like frozen, broken teeth. It is a landscape sculpted not by weather or erosion, but by the internal will of the planet itself. A slow bending and sinking that reshapes the crust over millions of years. As you sink deeper into the trench, the darkness becomes almost comforting. Here, without light or noise or movement, the scale of the world feels different. The surface ocean seems impossibly far away, almost imaginary, like a memory you're not entirely sure you experienced. Down here, you are closer to the Earth's interior than to the sun. You are brushing against the boundary where ocean meets mantle, where crust begins its long journey downward into heat and pressure, far beyond human reach. In this deepest realm, you begin to understand why trenches feel like "please do not disturb" signs left by the planet. They are quiet on purpose. They are places where the Earth conducts its slow internal business without wanting attention or interruption. Life moves gently, carefully. The landscape shifts in increments that take centuries to notice. Everything happens on a timeline so different from ours that it feels like stepping into another world's quiet cathedral. As you drift back upward along the trench wall, leaving its silent depths behind, you carry with you a sense of awe for this hidden dimension of the planet. Trenches are reminders that Earth is not just surface and ocean, not just mountains and plains, but a layered world with secrets folded deep into its crust, secrets that whisper only to those who are patient enough to descend. As you ascend from the trench walls and drift back toward the more level stretches of the deep, the water around you begins to move in ways that are subtle but unmistakable. It isn't the rushing sweep of surface waves or the rolling sway of tides. It's slower, thicker, more deliberate. The deep sea doesn't do anything abruptly, and that includes its currents. But make no mistake, water is on the move down here, and it's carrying with it the essentials of life. Nutrients, oxygen, chemical traces, tiny particles of drifting matter. Even the ocean floor, as it turns out, doesn't have to scavenge everything that falls from above. It gets groceries delivered by deep currents, instead of walking to the store. Most people imagine the deep ocean as static, a motionless void, where water simply sits because it has nowhere better to go. But the reality is wonderfully different. The deep ocean circulates in sprawling, looping pathways driven by temperature, salinity, and the planet's rotation, a global conveyor belt that can take a single parcel of water on a 1,000-year journey through the world's basins. These deep currents are slow, yes, but they are also unstoppable. They slip through valleys, glide over hills, and pour into trenches with the unhurried confidence of travelers who know every shortcut. The movement begins with something called thermohaline circulation, a grand phrase that basically means water goes where it is coldest and saltiest. Near the poles, cold winds chill the surface and sea ice forms, leaving salt behind as fresh water freezes out. The remaining water becomes denser and sinks. This dense water then begins creeping along the sea floor, hugging the bottom like a determined shadow. Once it starts, it doesn't stop. It moves southward or northward, depending on the basin, flowing along the contours of the planet with a patience that makes glaciers look rash. As this water moves, it carries nutrients with it. Some nutrients come from the slow decomposition of organic matter drifting downward. Some come from hydrothermal vents, cold seeps, and sediments dissolving into the water. Some hitch a ride from far-off region, carried by currents that link oceans like an invisible trade network. By the time the water arrives across the deep basins, it's holding a mix of chemical ingredients essential for life: nitrate, phosphate, silica, iron, the kinds of things plankton and everything else that eats plankton can't live without. But the deep currents don't just carry nutrients. They sculpt the landscape in quiet ways. When water flows through the deep at even a fraction of a knot, the movement can lift fine particles, push them across seabeds, and deposit them elsewhere. In places where the current picks up speed, around hills, ridges, canyons, it etches patterns into the seafloor, creating shapes and grooves you might mistake for ancient carvings. Elsewhere, the current slows, letting particles settle like dust in a forgotten room. Over centuries, these gentle forces change the topography in ways too subtle for the human eye, but obvious to the creatures who live here. Some animals rely on these currents, the way forests rely on rain. Filter feeders like sponges and deep-sea corals position themselves in places where currents bring a steady stream of microscopic food. They live like patient tea strainers, catching whatever nutritious specks pass by. For them, location is everything. Being just a meter too far from a dependable current could mean the difference between thriving and starving. In this world, real estate has nothing to do with sunlight and everything to do with how well the water delivers dinner. Other animals use currents for navigation. Some species of jelly-like creatures drift with the flow, conserving energy and letting the water decide where they travel. Certain fish ride the currents like slow-moving escalators, saving their strength for more important tasks, like avoiding predators or finding mates. Even microbial communities benefit. Nutrient-rich water promotes growth, which supports more life, which supports more predators, and so on. An entire miniature ecosystem can bloom simply because a current decides to take a left turn instead of a right. What's particularly remarkable is how these currents blend the histories of different parts of the ocean. Water that originates near Antarctica might eventually wind its way to the North Pacific. Along the way, it absorbs nutrients from decaying organic matter, minerals from vents and sediments, and oxygen from contact with the atmosphere before it sank. Every deep current is like an aged wine, carrying hints of where it's been, what it's touched, and how long it's been traveling. Scientists can sometimes trace a water mass like a detective following a scent, temperature, salinity, and nutrient levels acting as clues. Down here though, the currents don't feel dramatic. They don't slam into you or tug you aggressively. Instead, they move with the softness of a long exhale, nudging you ever so slightly in one direction, then another. You can drift alongside them and feel the faint pull, like a whisper of motion brushing past your skin. It's peaceful, rhythmic, almost meditative. Yet their importance cannot be overstated. Without deep currents, nutrients would build up in the abyss and starve the surface waters. the food webs above would collapse. These movements keep the ocean breathing, distributing life like a quiet, persistent heartbeat. They connect ecosystems that have never seen each other, transporting chemical threads that tie the entire ocean together. As you follow a current along the seafloor, watching particles shimmer as they glide past, you begin to appreciate how clever the ocean truly is. It doesn't rely on chance to move nutrients around. It has built-in delivery routes, slow, steady, essential. A system so vast and patient that it takes centuries to complete a single loop. And while the deep currents may not deliver groceries with the speed of a drone or the enthusiasm of a pizza driver, they do provide everything the ocean floor needs. No shopping carts, no checkout lines, just the planet's quiet commitment to making sure even its deepest, darkest corners are never forgotten, descending once more into the quiet, blue-black world of the deep. You begin to notice shapes on the seafloor that don't quite match the planet's natural style. Straight lines, sharp corners, surfaces too smooth, too symmetrical, too stubbornly metallic to have been crafted by geology. These strange forms appear gradually, first as vague silhouettes in the gloom, then as unmistakable relics of human ambition and misadventure. A shipwreck rests in the stillness, its hull half buried in sediment, its beams bent and softened by time. And yet, instead of looking forlorn or forgotten, the wreck glows with subtle life. It feels less like a graveyard and more like a thriving, underwater city that nature has reclaimed with impeccable interior design instincts. Shipwrecks and artificial reefs are some of the ocean's most surprising success stories. When a vessel sinks, the immediate assumption might be that it simply becomes debris, lost to rust and decay. But the ocean sees opportunity. The moment a structure settles on the seafloor, currents shift around it, shadows form beneath it, and new surfaces appear. Surfaces that hard-bodied organisms desperately crave in a world dominated by soft sediment. It's as if the deep sea receives a new building and immediately starts scouting for tenants. Metal, despite not being a natural substrate in the ocean, turns out to be an excellent foundation for life. Microbes are always the first to arrive, coating every available surface with thin films that glisten faintly under your lights. These microbial communities form the primer layer of underwater architecture, the biological equivalent of fresh paint. They help break down minerals, release nutrients, and prepare the site for the next wave of colonizers. Soon after, barnacles, tube worms, and sponges appear in clusters, each one settling into its preferred spot with the enthusiasm of people claiming rooms in a new apartment. Within a few years, sometimes even months, the once sterile metal becomes covered in living textures, transforming from industrial scrap into organic sculpture. Fish arrive next, and they do so with gusto. To them, a shipwreck is a luxury complex, complete with sheltered corridors, elevated perches, and dozens of nooks perfect for hiding, hunting, or simply avoiding neighbours. You can almost imagine them touring the wreck with clipboards, inspecting the layout, and deciding whether the place has good bones. The funniest part is how quickly some species become protective of the wreck, swimming in patterns that suggest property ownership. They treat the corroded beams and rusting metal like trendy new apartments with great rustic charm, which is code for the plumbing is questionable, but the location is unbeatable. As you approach one of the openings in the hull, you see a school of small fish darting in and out with the confidence of residents who know exactly which door is theirs. Larger predators patrol the edges, using the shadows for ambush. Anemones sway from the railings like hanging curtains. Even crabs crawl across the decks in slow, deliberate steps, as if checking for maintenance issues. The wreck is no longer a ship. It is a reef, a neighborhood, a fortress of life stitched together by shells, sponges, and patience. Artificial reefs, structures intentionally placed on the seafloor, follow a similar story. Old subway cars, concrete pyramids, decommissioned tanks, and specially designed frameworks all become hotspots of life once they settle into the ocean's rhythm. The key is complexity. Life loves edges, cracks, holes, and overhangs. The more corners an artificial reef provides, the more species arrive. It's not unlike the way cities grow around skyscrapers. More structure equals more opportunity, and more opportunity equals more residents. You drift through a channel formed by a fallen mast and the fractured side of the hull. The interior is dim but not empty. Light from your instruments reveals a cathedral-like chamber filled with drifting particles. Marine snow settling gently like dust in an abandoned attic. But the room is anything but abandoned. Shrimp cluster along pipes. Eels peek from holes carved into corrosion-softened metal. Sponges fan outward in rich colours that seem almost impossible in this darkness. Every inch has been repurposed by life, each organism contributing to the quiet hum of an ecosystem reinventing itself. Even the rust plays a role. Rusting metal releases iron, a trace nutrient that certain microbes use. The flaking surfaces create new textures for larvae to grip. Rust is not decay here, it's transformation. The ocean takes the ship apart, molecule by molecule. But in doing so, it creates new homes for species that depend on hard surfaces in a world dominated by mud. It's recycling on a geological scale. In some places, particularly around older wrecks, the structures become so integrated into the ecosystem that it's difficult to tell where the metal ends and the biology begins. Coral-like growths fuse to beams. Barnacles form thick crusts that take on the shape of the underlying hull. Entire communities become woven through the framework, turning cold steel into a warm, biological tapestry. There is a sense of peace here, not the eerie peace of abandonment, but the layered, purposeful peace of a neighborhood thriving in its own rhythm. The ship is no longer a story of loss. It is a story of renewal. It illustrates the ocean's uncanny ability to turn any structure, no matter how artificial, into a canvas for life. As you drift upward, leaving the wreck's silhouette fading beneath you, the transformation feels almost poetic. Above the waves, the ship once battled storms and carried human ambitions across the water. Below, it serves a quieter purpose, sheltering creatures who would otherwise have nowhere to anchor. The deep sea accepts what falls into it, not with destruction, but with creativity. Here, even the forgotten becomes essential. Even old metal gets a second life. And the fish? Well, they seem thrilled with their trendy new apartments, rustic charm and all. As you drift away from the corroded frames of shipwrecks and the swaying architecture of artificial reefs, the seafloor begins to smooth out again. Flat, quiet, unassuming. But appearances, as the deep ocean constantly reminds you, are deceptive. What looks at first like bare sediment soon reveals faint patches of colour. Pale blues, soft yellows, wispy whites, sometimes even rusty reds. These are microbial mats, the ocean floor's subtle works of living art. They don't glow with bioluminescence or tower like vent chimneys. Instead, they spread out as thin, layered carpets of microscopic life, quietly transforming chemistry into architecture. If the deep sea had a group of unsung engineers, the microbes living here would win every award and probably run the most successful real estate market on Earth in the process. A microbial mat is more than a smear of bacteria on the seafloor. It is a community, a bustling, perfectly organized society packed into layers thinner than a paperback book. Each layer is made of different types of microbes working together like tenants in a carefully zoned apartment complex, each specializing in a unique chemical niche. Light doesn't reach this far, so the microbes aren't engaging in the familiar business of photosynthesis. Instead, they perform a wide variety of chemical magic, using minerals, methane, sulfide, or even hydrogen as energy sources. To them, the seafloor is not barren, it is a buffet. The top layer of a microbial mat often contains bacteria that thrive in contact with oxygen. Even though the deep ocean is dark and chilly, the water is usually well oxygenated, and these surface microbes use it efficiently. They create a thin film across the mat, like a protective skin. Beneath them, oxygen levels quickly drop. By the second or third millimeter, entirely different bacteria take over, species that specialize in low oxygen or oxygen-free conditions. These microbes break down chemicals the upper layers produce, passing metabolic leftovers downward, like a microscopic assembly line. Keep drifting downward. Hypothetically, of course, since this is the size of a fingernail. And the chemistry changes yet again. Now you enter the domain of sulfate reducers, methane oxidizers, sulfur eaters, and other microbes that rely on exotic molecules no surface creature would ever consider edible. Each layer exists because the layer above creates the exact conditions needed for the layer below. It's a kind of microbial urban planning. They build their world together, millimeter by millimeter, until the mat becomes a vertical stack of chemical specialization. If microbes could draw up property maps, they'd have zoning codes more complex than any coastal city. What makes these mats even more impressive is how they shape the landscape around them. Some mats bind sediment grains together, preventing erosion in areas where currents might otherwise sweep everything away. Others produce sticky biofilms that trap particles drifting down from above, gradually building up the seafloor in slow, steady increments. Some mats even create small ridges or lumps, tiny hills, sculpted not by tectonic forces but by communities of organisms too small to see. The result is a miniature terrain. Gentle mounds, subtle ripples, soft plateaus. It's almost cute, in a geological sense. The mats also play a crucial role in the deep ocean's chemistry. By breaking down organic matter, they recycle nutrients that other organisms depend on. They convert methane into carbon dioxide, sulfide into sulfate, and dead organic particles into usable minerals. Through these processes, they act like vast, silent regulators of the ocean's chemical balance. You could think of them as environmental managers who never sleep, never argue, and never stop working. It's unclear whether they hold meetings, but if they do, they're probably very efficient. Despite their tiny size, microbial mats have an outsized influence on life in the deep. Larger animals often graze on the mats, scraping the surface for its nutritious film of bacteria. Some worms tunnel beneath the mats, mixing oxygen-rich water into deeper layers and inadvertently expanding the living space. Crabs and shrimp move across them, stirring sediment and carrying bacteria on their legs, like accidental gardeners spreading seeds. Even the faintest shift from a passing current can introduce new particles the microbes quickly incorporate into their chemical economy. In some locations, mats develop at the edges of chemical seepage zones, where methane or sulfide flows up through the sediment. Here, the mats take on brighter colours and form thicker layers, responding to the rich chemical supply, like plants responding to fertilizer. You can sometimes see shimmering surfaces, subtle sheens left by microbial activity altering the chemistry near the surface. In these places, the mats resemble oversized quilt squares, each patch a slightly different color and texture depending on which microbes dominate. While most of their architecture remains low to the ground, microbial mats are anything but timid. They expand across the seafloor, inch by inch, colonizing any stable surface they can reach. They are, in essence, real estate moguls of the deep, claiming territory, building upward, and leasing chemical space with the confidence of organisms that have been doing this for billions of years. Long before forests or reefs or animals with spines existed, mats were mastering the art of land management. And there is a quiet beauty to them. A patch of pale green mat draped across dark sediment looks like frost on stone. A white mat glowing faintly under your lights resembles a delicate dusting of snow. Thin, rippling layers move slightly with the water, as if breathing. If you hover long enough, watching the colors shift subtly from one patch to another, it becomes easy to forget that everything here is microscopic. The effect is both serene and humbling, a reminder that even the simplest organisms can create landscapes worth admiring. As you glide onward, leaving the patterned mats behind, you carry a new appreciation for the smallest engineers in the deep sea. They don't build towers or reefs or forests. They don't sparkle or swim or impress with size. But they shape the environment quietly, steadily, and with astonishing skill. In the deep ocean's vast and silent world, microbial mats prove that even life measured in microns can leave footprints on the planet. Tiny, magnificent footprints in the fabric of the seafloor. As you move beyond the quiet, quilted fields of microbial mats, the water around you feels different. Not louder, not busier, but heavier, with the subtle presence of creatures whose lives revolve around stillness. The deep sea is full of predators, but not the fast, tooth-flashing hunters people imagine when they hear the word. No great chases, no lightning strikes. Down here, predators have traded speed for strategy, urgency for patience. Everything moves slowly, and yet danger lingers in every quiet corner. It's a paradoxical world of tense calm, a place where predators drift like shadows and meals are caught not by force, but by impeccable timing. If proof were ever needed that patience can be a hunting strategy, the deep sea has entire species that built their resumes on it. One of the most iconic predators in this realm is the sleeper shark. Even its name sounds like someone describing a creature that never feels hurried. These sharks glide through the deep with massive bodies and slow, deliberate movements. They are among the largest predators of the abyss, yet they never seem rushed. No frantic tail beats, no thrashing, no quick turns. Their motions look as if someone turned the playback speed down and forgot to reset it. But this slow pace is not weakness. It is adaptation. Perfection honed for a place where conserving energy is the difference between thriving and starving. A sleeper shark's eyes are small and pale, its skin smooth and thick, and its shape broad like a moving shadow. It can grow to lengths that rival the world's most famous sharks, yet remain almost ghostly in its presence. Part of this is because the deep dims everything, but part of it is the shark itself. It moves quietly, deliberately, coasting on currents when possible, conserving every scrap of energy. It it does not chase much. Instead, it relies on ambush and opportunity, finding prey that drifts too close, or scavenging carcasses that settle on the seafloor. In a realm where calories are rare, being adaptable is as important as being powerful. And while sleeper sharks are the iconic large predators, they are far from the only ones practicing the art of stillness. Amphipods, tiny crustaceans that look like armored fleas, are also predators in their own right, though at a drastically smaller scale. They might not be the first creatures you picture when imagining deep-sea hunters, but amphipods are devoted scavengers, quick to exploit anything edible within reach. Their small sizes belie their ferocity. Give them a meal, and they arrive in astonishing numbers, swarming with a determination that seems almost cheerful. If the sleeper shark is the quiet, patient stalker of the deep, amphipods are the hyper-efficient cleanup crew that leaves nothing behind. Despite their differences, both creatures share a common survival tactic: endurance over speed. Down here, food doesn't sprint past. It descends, drifts, or dies, and sinks slowly. Predators have evolved to match this pace. Amphipods wait for chemical cues of a meal, often covering distances much larger than their bodies suggest possible, all without expending much energy. Sleeper sharks use smell and vibration rather than sight, detecting faint signals carried through the still water. They might approach a meal with the enthusiasm of someone walking toward the last remaining donut, but at the determined pace of someone making sure they don't slip on ice. You drift deeper into the dark, and other predators appear. Rat-tail fish with long tapering bodies hover just above the seafloor, moving only when necessary. Some species have heads that look oversized, exaggerated by the lack of strong muscles in the rest of their bodies. Their jaws can snap forward with surprising speed, a sudden burst of motion designed to scoop up unsuspecting shrimp or worms. It's an efficient method: save energy, strike only when sure, and return immediately to stillness. In many ways, they have perfected the art of doing nothing until doing something matters. Then there are grenadiers, which look perpetually puzzled by their own existence. Their slow movements and large eyes give them the air of contemplative philosophers wandering the deep. But their feeding strategy is elegant. Drift quietly, wait patiently, and use keen senses to detect small disturbances. They are not ambushers, so much as opportunists who understand that in a world of slow-moving meals, being the first to notice an opportunity often matters more than being fast. Even stranger are the deep-sea lizardfish, which lie motionless on the seafloor like statues. Their bodies are built for bursts of speed, but only tiny bursts, almost comical in their brevity. They remain still for hours, waiting, until a small creature dares to pass within striking distance. Their patience is almost unnerving, the biological equivalent of someone staring at a closed door for an entire afternoon, just to be the first to catch a package delivery. The tension of these predator-prey relationships is strangely soothing. There's no chaos, no frantic motion. Every interaction is a careful negotiation of energy. One wrong move wastes calories that might take months to replenish. Down here, efficiency is everything. Even the simplest organisms understand the cost of movement. The deep sea is not a world of constant pursuit. It is a world of watching, sensing, deciding. The predators know this well, and their bodies reflect the rules of a place where motion is precious. As you hover in the quiet water, observing these patient hunters glide or perch or drift, you can't help but appreciate the elegance of their strategies. Nothing here acts out of haste. The deep sea rewards endurance, not aggression. The sleeper shark drifting past seems as relaxed as a creature can be, while still being a top predator. The amphipods scurrying over a scrap of food move with purpose, but not frenzy. Everything feels measured, controlled, precise. Predation here is not about speed, it's about time, it's about presence, it's about knowing that sometimes the best way to catch a meal is simply to wait longer than everyone else. Down here, patience isn't just a virtue, it's a way of life. And every creature around you is proof that, in the deep ocean, patience is a hunting strategy. As you continue drifting through the deep, the terrain ahead begins to shift into a world that seems almost sculpted rather than grown. What first appears to be a cluster of strange, pale branches emerges from the dark, then another cluster, then an entire grove. These are deep-sea coral gardens, vast, delicate wonderlands built slowly, patiently, over centuries. If there were ever a group of creatures qualified to win the world's slowest interior decorators award, these corals would accept it proudly, assembling their homes millimetre by millimetre with the casual timing of organisms completely unbothered by deadlines. Unlike their tropical cousins basking in warm, shallow sunlight, deep-sea corals thrive in permanent night. They don't rely on photosynthetic algae. Instead, they feed on whatever drifting organic particles and small animals drift by in the slow, cold currents. Without the need for sunlight, they can live at astonishing depths. Perched on rocky outcrops and ridges, where water flows steadily and carries a reliable supply of microscopic meals. Their gardens bloom where the seafloor becomes textured enough for them to gain a foothold, on ledges, knolls, old volcanic rock, or the remnants of long submerged geology. Given the chance, they create forests that stretch for kilometers. The shapes of these corals are extraordinary. Some branch out into elaborate fans, wide and delicate as lace. Others form thick, twisting skeletons that look like miniature trees carved from ivory. Some grow into tall spirals, curling upward like question marks frozen in place. Each colony has its own architectural flair, but all share one defining trait: a dedication to slow, deliberate construction. Coral skeletons may grow only a few millimeters per year, occasionally less. A coral the size of your arm may be older than entire cities on land. A coral the size of a small tree may predate the invention of written languages. The gardens are quiet, but they are far from lifeless. Look closer, and life reveals itself in the cracks and crevices. Small fish weave between the branches with a cautious grace, taking advantage of the maze-like shelter. Crustaceans scuttle along the surfaces, picking at stray particles. Feather stars cling to the coral arms, spreading their feathery appendages like living flowers that filter the cold currents for food. Among the branches, brittle stars twist their long arms with eerie fluidity, their movements slow but strangely elegant. Even worms make their homes inside coral skeletons, carving microscopic tunnels that you'd never believe existed unless you peered close enough. Deep-sea corals transform the terrain around them. They provide structure in a world dominated by soft sediment and open expanses. They create nooks where small creatures hide from predators, platforms where filter feeders can rise slightly into stronger currents, and intricate passageways where life can linger and forage. The gardens become microcosms, entire ecosystems orbiting around a community of silent builders who never move but shape everything. What makes these gardens even more mesmerizing is their resilience. Deep-sea corals grow in environments with almost no light, near freezing temperatures, and food supplies that arrive unpredictably. Yet they endure. Their slow growth reflects extreme efficiency. Every bit of energy they capture is used sparingly, converted into just enough skeletal material to extend a branch or strengthen a base. Their patience is geological in scale. They grow not for today, but for centuries into the future. They exist as living clocks, ticking forward with molecular precision. But the deep ocean, being perpetually surprising, also offers contrast even here. Some corals grow tall and airy, their branches spaced wide like delicate chandeliers. Others grow dense and compact, forming knotted tangles that resemble underwater hedges. There are species that branch in 2 dimensions, like curtains fluttering in the currents, and others that branch in 3, forming complex shapes that look like frozen fireworks. Every colony seems to have its own artistic preferences, as though the corals received the same vague instructions and then interpreted them wildly differently. The colours, muted but captivating, reflect the minerals in the skeletons. Creamy whites, pale oranges, dusty reds. In your light, some look almost translucent. Others gleam with a porcelain sheen. Without sunlight, their hues remain subtle, but in a way that amplifies their beauty. Nothing here shouts. Everything whispers. In the midst of these gardens, predators move quietly. Small fish hover close to the corals, sometimes blending in so well they seem like extra branches until they flick away. Crabs tuck themselves into crevices, their claws hidden from view. The corals themselves do not hunt. They capture food passively with tiny tentacles. But by providing structure, they invite an entire food chain to flourish. When the currents shift, carrying new particles, the polyps extend their tentacles in unison, a synchronized feeding dance that looks like a forest raising its leaves to greet an invisible sun. The most humbling part of drifting through these gardens is realizing that some of the corals before you may have begun growing before humanity understood the shape of the continents, before the concept of time was measured in anything but seasons. They grow slowly, survive quietly, and shape ecosystems without fanfare. Their patience is not just a trait, it's a legacy. And so, as you float through this silent forest of calcium carbonate artistry, you cannot help but smile at the thought. These corals really are the world's slowest interior decorators. But what they lack in speed, they more than make up for in craftsmanship. Millimetre by millimetre, century by century, they turn empty water into a maze of life, proving that sometimes the most breathtaking creations on the planet are the ones that take the longest to build. As you drift onward from the quiet geometry of coral gardens, the deep seems like it should be the most silent place on Earth. No waves crash here. No wind murmurs overhead. No human chatter filters down from above. It feels, visually at least, like a place designed for perfect stillness. But then something unexpected reaches you. Not through sight, but through vibration. A faint crackle, a distant rumble, a soft clicking that seems to come from everywhere and nowhere at once. For a world drowned in darkness, the deep ocean is surprisingly loud. Sound behaves differently underwater. In air, sound travels by nudging molecules that are spaced relatively far apart. But in water, the molecules are close, dense, and ready to pass along vibrations with far more efficiency. A sound that fades after a few kilometers in air might travel hundreds or even thousands in the ocean. Down here, sound is the main courier of information. It's the deep sea's broadcasting network, carrying messages across distances where light never reaches and movement is slow. If sight is nearly useless, sound becomes the one reliable way to sense the world. The first type of sound you notice is the most surprising: the tiny crackles and pops of marine life. Much of this comes from small crustaceans, snapping shrimp and their deep relatives, each producing sharp, tiny clicks made by snapping specialized parts of their claws. It may not sound impressive when described, but multiply it by thousands of individuals scattered across the dark, each snapping whenever they feel like it. And the result becomes a continuous crackling background noise. It's nature's version of bubble wrap popping, except the shrimp do it constantly, enthusiastically, and with absolutely no regard for anyone who might be trying to meditate. Some shrimp species create their snaps by closing their claws so quickly that the water collapses into a tiny bubble, which then bursts with a sharp sound. It's a miniature explosion happening millimeters wide but loud enough to confuse sonar. A single shrimp snap isn't much, but an entire shrimp community? That becomes a soundscape, one that researchers sometimes call biological static. It's not random noise though. Some predators can listen for changes in the pattern, detecting disturbances that signal prey or danger. In the deep sea, even chaos contains clues. But shrimp aren't the only contributors. Fish produce low rumbles and thumps by vibrating their swim bladders, internal air-filled sacs that double as both buoyancy devices and drums. Some fish use these sounds to communicate in the dark, sending out coded pulses to claim territory, attract mates, or simply announce their presence with the confidence of creatures who know they are nearly invisible. These vibrations can travel long distances, bouncing off rock outcrops, canyon walls, or even the boundaries between layers of water with different temperatures. To ears adapted to the deep, every vibration reveals a story. Someone moved, someone fed, someone wandered too far from home. Then there are the geological voices. The seafloor is always shifting slightly, and when sediment moves or microfaults slip, faint tremors echo through the water. These are quiet, subtle, more like the distant groans of an old house settling. But the deep hears everything. A small tremor hundreds of miles away might whisper through the layers of water before finally fading. Some trenches channel these vibrations like enormous acoustic hallways, carrying sound farther than seems possible. You find yourself listening to the earth itself, murmuring under its breath. Currents add their own signature, a soft, constant rush, like wind passing through leaves but deeper, thicker, and more enveloping. When water moves through tight spaces, between boulders, across ridges, through narrow channels, the flow produces fluctuating tones, sometimes low and droning, sometimes high and whistling. These aren't random noises, but acoustic textures shaped by the underwater landscape. A coral forest hums differently than the flat plain beside it. A canyon resonates like a cathedral. If you had the ears of a whale, the deep ocean might sound like a symphony, each habitat offering its own layered harmonies. And of course, there are the giants, the whales themselves, whose calls can travel farther than any other creature's voice on Earth. While you're far from the depths where most whales roam, some of their low-frequency calls still reach into the deep. These sounds roll through the darkness in long, vibrating waves, distant but unmistakable. They feel less like noise and more like slow-motion thunder, humming through your chest in a way that makes the entire planet feel alive. For the whales, these calls are lifelines, ways to communicate across basins, guide migrations, and keep track of companions in a world without landmarks. Human sounds make their way down here too, though they are less poetic. Engine rumble, distant propeller thrum, the metallic heartbeat of shipping lanes far above. The deep ocean doesn't pick favorites. It records all vibrations impartially. But down here, surrounded by natural soundscapes shaped by millennia of quiet life, the mechanical hums feel out of place. They don't blend, they intrude. Yet despite the diversity of noise, the deep never feels overwhelming. Sounds arrive softly, layered in ways that leave space between them. Silence isn't absent, it is simply shared with sound. The world feels alive, but not crowded, busy, but not chaotic. It's a soundscape built on patience and distance. As you hover quietly, letting the noises wash past, you begin to appreciate that the deep ocean communicates not with sights or colours, but with vibrations. The crackle of shrimp, the rumble of fish, the sigh of currents, the drone of distant geology. It all forms a tapestry of tiny events, each telling something about life in the dark. The deep might look empty, but listen closely, and you'll hear an entire community in conversation. And somewhere in that chorus, a tiny shrimp undoubtedly snaps again, punctuating the silence like someone popping bubble wrap in the middle of a library, blissfully unaware that the whole room can hear it. As you glide away from the humming soundscape of the deep, a strange feeling settles over the water around you. Movement, not just of currents or drifting particles, but of purpose. The deep ocean, for all its stillness, is also a crossroads. Invisible highways stretch across the seafloor, carved not by stones or sediment, but by instinct, memory, and generations of silent travelers. These are the migration routes, ancient pathways traced by eels, whales, fish, and creatures that cross entire oceans with an accuracy that would embarrass any human juggling 3 map apps, a GPS, and a frantic text from a friend trying to give directions. The deep ocean seems like an unlikely place for travel. It's dark, cold, and mostly featureless. There are no signposts, no continental outlines, no visible cue that says, turn left at the trench and continue straight for 3,000 miles. And yet animals navigate it with a precision that borders on mystical. Some follow faint gradients in temperature or chemicals. Others sense the Earth's magnetic field as if carrying a built-in compass. Some detect pressure differences or minute currents. Together, these cues create an internal map, a silent guide that leads them through thousands of kilometers of open water. Among the most astonishing travelers are the eels. They live their adult lives in rivers and coastal waters, sometimes thousands of miles from the deep. Yet when the time comes to breed, they all follow an ancient route out into the vast Atlantic. For generations, these migrations remained one of biology's quiet mysteries. The eels slipped away from their homes, vanished into the deep, and swam toward a place they had never seen, guided only by instinct and faint environmental whispers. Their destination, the Sargasso Sea, a calm patch of ocean bounded not by land, but by circulating currents. They spawn there, and their tiny transparent larvae begin the long return journey across ocean basins, drifting for months before finding the rivers and coasts their parents left behind. What makes this migration so remarkable is that it crosses multiple layers of the deep ocean, twilight zones, midnight zones, and even areas brushing the seafloor. The eels rise and sink in a rhythmic pattern each day, riding deep layers of water like travelers choosing the perfect altitude for a flight. They measure their path not by landmarks, but by the chemical signatures and temperatures of the water around them. In some ways, they navigate the ocean the way someone might navigate a dark room using only touch and intuition. Slowly, confidently, knowing each step by feel rather than sight. Then there are the whales, the giants who journey along routes that span hemispheres. many migrate through deep ocean corridors, diving down hundreds or even thousands of meters during their long voyages. Their migrations are shaped by cycles of feeding and breeding. Summers spent feasting in cold, nutrient-rich regions, winters spent in warmer waters to give birth. But even when they journey through these vast, dark basins, they never seem lost. Their calls travel for hundreds of miles, bouncing off underwater geological features in ways that let them hear the shape of the landscape around them. They follow ancient acoustic corridors, using sound like a living sonar map. Some species dive deep enough to flirt with the seafloor itself. Sperm whales regularly descend thousands of meters, using the deep ocean floor as a backdrop for hunting squid and other prey. Their migrations weave vertical routes through the planet's largest environment, like dancers moving through layers of invisible stages. A single journey might take them through warm surface waters, cold, deep currents, and the silent plains beneath. They carry the deep with them in their bones, emerging into the light only to breathe before sinking again into darkness. Other travelers are far smaller, but no less determined. Certain fish species migrate across basins following faint chemical trails left by plankton blooms or distant upwelling zones. Some crustaceans drift along deep current pathways, hitchhiking for hundreds of miles without ever using a single muscle unnecessarily. Tiny gelatinous creatures ride internal waves, massive, slow-moving pulses of water that travel along density boundaries in the deep. These internal waves act like underwater conveyor belts, transporting animals across the seafloor without them ever needing to swim. Even sharks embark on migrations that cross entire oceans. While surface-dwelling species often travel along warm currents, deep-diving sharks follow thermal layers, slipping into different water temperatures the way someone might adjust a blanket on a long journey. Some species show up thousands of miles from where they were tagged, having traveled routes that scientists can't fully explain. Their navigation appears to rely partly on geomagnetic cues, an internal compass tuned to the Earth's magnetic field. It's the kind of biological instrument that would make any human navigator jealous, especially the ones who turn the map upside down to see if it makes more sense. What unites all these migrations is the calm determination woven through them. Nothing rushes, nothing flails. The deep doesn't allow frantic speed. Not enough food, not enough light, not enough energy. So migration becomes a slow, measured journey, one that blends endurance with intuition. The animals follow the contours of the seafloor, the pull of currents, the tug of magnetism, the faint hint of chemicals drifting on the water. Their paths are not straight lines, but wandering arcs shaped by the deep's hidden architecture. And along the way, each species leaves a soft signature, faint trails of motion, wisps of chemical cues, vibrations barely strong enough to notice. The deep stores these traces briefly before they vanish again into stillness. To you, drifting silently above the seafloor. The migrations are invisible unless you happen to be in the right place at the right moment. A shadow moves. A shape glides by. A distant call echoes. Then the migrants pass, leaving the deep just as quiet as before. Yet these journeys carve meaning into the darkness. They connect distant worlds, polar seas to tropical waters, rivers to the open ocean, shallow coasts to deep trenches. They transform the seafloor from a static landscape into a living, moving network of pathways. They remind you that even in the deepest, darkest parts of the planet, life is never isolated. It moves, it travels, it remembers where it's going. And somehow, without satellites, without compasses, without apps, it arrives exactly where it needs to be. Even the best human traveler, toggling between 3 map apps, would be impressed. as you drift through the deep. Surrounded by ancient migration routes and shadowy wanderers, it becomes clear that none of this world would be known to us. None of the hills, the gardens, the glowing lives, the silent predators, without the quiet arrival of technology. Long before humans ever dreamed of satellites or space telescopes, the deep ocean kept its secrets with an unbroken confidence. No light, no access, no air. Perfect. The deep was an expert at staying hidden. But then humans did what humans do best. We built machines to go where we cannot. And the deep, with all its pressure, cold and darkness, met the first explorers that could finally withstand its terms. Remotely operated vehicles, ROVs, were among the earliest ambassadors to this world. They look slightly awkward at first glance. Metal frames, bundled cables, lights bright enough to startle even the most stoic deep-sea creature. But there is beauty in their purpose. An ROV lowers slowly through the water column like a thoughtful guest arriving at a sacred library. It carries cameras that don't blink, robotic arms that move with steady precision, and sensors that translate darkness into data. An ROV doesn't hurry, doesn't tremble, doesn't suffer from fear of the unknown. It simply descends and watches, letting the deep reveal itself at whatever pace it prefers. The first ROVs were connected to their support ships with thick cables, sending signals up and down through the water like high-tech umbilical cords. Over time, these systems evolved into graceful, maneuverable vehicles capable of drifting with surprising delicacy. They can hover beside coral branches without disturbing a single polyp, glide over sediment without stirring up a cloud, and place themselves in narrow crevices to study creatures that would disappear at the slightest vibration from a human diver. They are observers with perfect breath control, permanent, quiet, and patient. Autonomous underwater vehicles, or AUVs, took the idea further by removing human piloting altogether. These robots are programmed with missions, released like thoughtful explorers, and left to chart their own paths. They move through the deep with a calm determination, following pre-planned trajectories or adjusting their routes based on environmental cues. AUVs capture wide sweeps of data, mapping the seafloor with sonar, tracing chemical signatures, documenting everything from trench walls to deep currents. They roam in the silence with a kind of robotic independence, their lights flickering gently in the dark as they search for answers to questions humans haven't yet learned to ask. Then there are the sensors, small, subtle instruments scattered across the ocean like tiny listening stones. Some attached to moorings anchored to the seafloor, measuring temperature, salinity, pressure, and chemical changes year after year. Others drift with currents, traveling thousands of miles while collecting information that helps researchers understand the deep's inner workings. Still others cling to migrating animals, hitchhiking on whales or sharks, and gathering data with every twist and turn. These sensors are nearly invisible, but without them, the deep ocean would remain a blank map in our collective knowledge. All of these technologies share one trait. They explore without taking, without loud footprints, without leaving anything behind. In a world where human tourism on land often leaves discarded coffee cups and misplaced snack wrappers, underwater robots are wonderfully considerate. They're the only tourists who never litter. They arrive, gather observations with impeccable manners, and leave with nothing but data. The deep ocean, which has endured centuries of nets, anchors, and discarded objects, likely appreciates this new, more respectful generation of visitors. What makes this technology even more remarkable is how peaceful its exploration truly is. Submersibles, whether manned or robotic, move slowly, not because they have to be polite, but because the deep demands it. Fast motion stirs sediment, stresses animals, and risks damaging fragile habitats. So the machines drift gently, adjusting thrusters in tiny bursts, gliding with the patience of underwater monks. Their lights reveal only what is necessary, brief islands of brightness in the perpetual night. The footage they bring back is astonishing. A single ROV dive can uncover landscapes that feel foreign even to seasoned scientists. Gardens of glass sponges, mountain ridges rising into nothingness, fields of strange organisms blinking with chemical light. AUVs capture sonar maps so detailed that a scientist on a ship can see the ripple patterns in sediment hundreds of meters below, like fingerprints left by the planet itself. Sensors record temperature changes that hint at unseen currents or chemical shifts, signaling new biological activity. These technologies don't just collect information, they return perspective. Watching the deep through an ROV camera is like stepping into a world where time has a different meaning. You learn patience by observing creatures that move once every few minutes, plants that grow once every few years, and mountains that shift once every few centuries. Technology grants humans the ability to slow down long enough to witness these rhythms. Yet despite all their engineering, these machines remain humble. They do not dominate the deep. They do not reshape it. They drift. They measure. They watch. And every discovery they make reminds us how little we truly know. With each dive, humanity's understanding of the ocean grows clearer. Yet the deep always keeps a few secrets tucked away, just beyond the reach of any sensor or camera. It reveals itself not all at once, but in gentle increments, as though teaching us that some knowledge must be earned slowly. As you watch an ROV's lights fade into the dark, or imagine an AUV continuing its solitary path across an unseen basin, you realize that technology has not conquered the deep. It has simply found a way to ask the deep questions without demanding answers. And down here, that is the most peaceful kind of exploration possible. As your long descent through the deep ocean nears its end, the world around you settles into its familiar, timeless stillness. The seafloor stretches ahead in a calm expanse, an endless landscape without haste, without hurry, without the frantic pulse of the surface world. Down here, everything unfolds slowly, deliberately, as if the ocean floor exists in a different chapter of time altogether. And in a way, it does. This place isn't just a location. It's a mood, a rhythm, a quiet story written in geology and biology instead of ink. You think back to the shimmering twilight you first passed through on the way down. It felt like entering a cathedral of dim blue, a gentle invitation to leave noise and urgency behind. As you traveled deeper, the ocean didn't roar or push or demand attention. It simply opened its arms wider, revealing one layer after another with the patience of someone turning pages in the softest, slowest book ever written. Each chapter was different, sediments drifting like powdered stardust, vents exhaling shimmering heat, seeps bubbling with quiet chemistry, hills rising in modest swells, layers of migrating life commuting by candle glow, corals building palaces grain by grain. And through it all, the deep remained calm. Even its predators moved with a stillness that felt more like meditation than menace. Even its currents whispered rather than surged. Even its soundscapes, surprisingly full of life, settled into a steady background texture rather than a clamour. The deep does not crave attention. It allows discovery only at the pace it chooses. You don't explore this world so much as you are allowed to pass through it. What strikes you most is how little in the deep ocean tries to compete for notice. On land, ecosystems often scream their existence, birds calling, leaves rustling, rivers shouting over rocks. But down here, life communicates through subtle glows, chemical traces, faint clicks, and patient movement. Beauty isn't displayed, it's revealed. The deep ocean feels like someone whispering an ancient story directly into your awareness, not loud enough for anyone else to hear, but unmistakably present. It becomes clear that serenity isn't just an attribute of the deep, it is the deep. Almost every creature here has adapted to a lifestyle built around conserving energy, avoiding sudden movement, and blending into the darkness. It's not laziness, it's strategy. Down here, rushing gets you nowhere. The ocean rewards those who wait, drift, or simply exist without fuss. The world above is filled with deadlines and bright lights and car horns. The world below is shaped by patience, shadow, and long, uninterrupted silence. You remember the first moment you saw bioluminescence shimmer in the dark, a quiet flicker of life writing its presence into the void. You recall the grandeur of mineral towers rising from vents, built not by architects but by chemistry. You remember seeing deep-sea coral gardens sculpted slowly across centuries, and realizing that beauty doesn't always need color or sunlight to thrive. Every stop along the way felt like discovering a forgotten chapter of Earth's story, one that few readers ever reach. And perhaps that's what makes this environment so moving, its refusal to change its pace for anyone. Technology may descend into the depths, ROVs, AUVs, sensors with the patience of monks, but even they must work within the rules the deep has set. No rushing, no noise, no shortcuts. Exploring the deep is less like investigation and more like listening to a story being told by someone who has all the time in the world. Your mind drifts to the migrations that pass silently through the water, eels crossing basins, whales navigating by sound, tiny creatures riding currents like invisible highways. None of them hurry, none of them panic. Their movements are rehearsed in the planet's oldest patterns. Watching them is like reading sentences written on an invisible page. Each journey a line of text that continues long after your eyes leave the spot. It's impossible not to feel small here, but not in the diminishing way people sometimes describe. It is a soft smallness, a comfortable one, like recognizing that you are one voice in a much larger, older choir. The deep doesn't care about fame or fear or achievement. Its serenity is steady, impartial, and welcoming. When you drift over a trench or hover near a coral, the ocean doesn't ask anything of you. It simply exists, and somehow that is enough to quiet the noise inside your own thoughts. In many ways, exploring the ocean floor feels like reading the quietest story on the planet. One written in slow geologic strokes, illuminated by the faintest of lights, whispered by creatures who have mastered the art of surviving with grace rather than struggle. You turn its pages carefully, knowing that each one holds a world that has persisted for millions of years without ever needing applause. Eventually, your journey arcs back toward the upper darkness, and the seafloor begins to drift away beneath you. But its serenity lingers. It rests quietly in your awareness, like a memory of soft light or a calming melody that continues even after the music stops. And as you rise, one final thought settles in with gentle certainty. If the surface world ever needs a sanctuary designed entirely for introverts, a place free of noise, crowds, and unsolicited conversations, the deep sea has already perfected the blueprint. It has been Earth's greatest introvert sanctuary all along.